Our next speaker, Cynthia Dwork, who doesn't need an introduction as an inventor of differential privacy. So she's going to share with us a broader perspective regarding privacy, fairness, and just in general ethical use of personal data.
Okay, so actually I'm not going to talk about privacy, but I am going to talk about fairness and about some things that I've been struggling with for something like 15 years. So I've been working in the theory of algorithmic fairness for about 15 years, and I had hoped that fairness would be as amenable to mathematical rigor as privacy-preserving data analysis has been. But that has not proven to be the case, and the difficulties run the gamut from competing desirable but mutually incompatible, provably incompatible fairness goals, to deep philosophical questions regarding the very meaning of the outputs of even an ideal algorithm that's trying to produce probabilities. Okay, so ultimately, this talk is going to focus on race and the use of race in medicine. And so I just want to put the caveat out that we understand that race is a social and not a biological phenomenon, and that's where the problem lies. So recently, I realized that something that I suspected might be problematic could indeed, under certain circumstances, be deeply disturbing. So I wanted to tell you about that, about what's bothering me so much. So a scoring function is just a function that maps individuals to a number, or to numbers between 0 and 1. And they're frequently interpreted as probabilities. So what is the chance that this particular person, X, will experience serious dermatologic reaction to carbamazepine? And so assume that there's actually a ground truth scoring function, P star. We don't have access to it, but assume that it actually exists. There's a side question of what is the meaning of the probability of a non-repeatable event, but we're just going to cabin that for now. So this true ground truth probability, P star of X, cannot be accessed, but real-life historical outcomes, so survival information or real cases of real people who got the medication and either did or didn't have severe reactions are known. And we assume that those outcomes are drawn according to the P star values, the true probabilities, okay? And we also assume, and correctly, that the distance between two scoring functions is well-defined. It's a number somewhere between 0 and 1, and it's well-defined, okay? So this is your typical risk assessment setting. So there's a trend in the literature to look at multi-group fairness notions. And these are notions that, some of these notions, tend to look at fairness for a scoring function as accuracy. So fairness as accuracy is the notion. So you can have a collection C of sets, and I've drawn a collection that's mutually, the sets do not have to be disjoint, they can intersect arbitrarily. You should assume that they're generally large sets. So for a set collection C, a function f is said to be accurate in expectation simultaneously. A multi-accurate, function is accurate in expectation simultaneously on every set in the collection. So what that means is if you view any of these sets in isolation and see what is the behavior of the scoring function on it, then it is correct in expectation. So if a third of the members of S experience some positive outcome, then the scores on average for the members in S should be approximately 1/3. And there's always a multi-accurate predictor because the truth itself is multi-accurate. So one exists. Great definition. And it's really conceptually easy to build a multi-accurate predictor from training data, some data with Boolean labels. So you start anywhere. So you might start with some algorithm that assigns to X just some vanilla starting point probability of a half, or A might be some incredible artisanally trained algorithm that you've been building over 5 years. training over 5 years, or it may be set to some global base rate for your population, okay? And the general framework is as follows. While there's some set in the collection on which F is far from accurate in expectation, so there are some numbers there that say how far is far, then while that happens, pick such a set and nudge all of the scores of the members of that set in the right direction by some prescribed amount. Okay? And the general idea is, if you've defined things carefully, every nudge will move F substantially closer to the truth. And the advantage of this is it means that this process terminates. And we know exactly, an upper bound on how many steps it's going to take. Okay? Now, I'm going to come back to this slide in a moment. Moving on, the legal philosopher Deborah Hellman has done a lot of work studying when is discrimination wrong. And she has come up with a notion which she calls a duty not to compound. So let's just see what she has to say about this word, compound. That word captures the two morally relevant facets of the later actor's involvement with a prior injustice. A compound, understood as a noun, is a mixture or blend. The actor must interact with the injustice or the effects of the injustice to bear some responsibility for it. Second, to compound, understood as a verb, is to increase or magnify. The actor must not only harm the victim, she must amplify the original injustice or translate it to a new sphere. So an example of compounding, especially in the red sense here, is it's known that battered women are likely to die earlier than the average women of the same age. And this is true whether the woman stays with or leaves her batterer. So should the insurance company take into account the fact that battered women are victims of wrongdoing when determining whether to include this relevant risk factor? Okay. So Hellman argues no, that this is just compounding a previous injustice. You can agree or not agree, but I hope that the example clarifies what's on her mind. Okay. So let's consider the real question in college admissions. Who, if admitted now, will donate a building within 25 years? So P star of X, let that be the probability that X, if admitted, will donate a building within 25 years. So here's what led me to that sort of Edvard Munch moment of screaming. Okay, less intergenerational wealth positions Black candidates on average below white candidates in terms of being able to fund a building. So for this example, we're going to assume that A of X is just the base rate for the population as a whole. And we're going to assume that one of the groups that we consider in multi-accuracy is the group of people who are racialized as Black. Now, I want to make a comment here. In the multi-accuracy literature, the goal of having racial groups as being parts of the set collection was precisely to make sure that algorithms that are being used to allow people to do something or grant admission and so on are not systematically discriminating. The problem is that, well, you'll see. Okay, so here we go. So suppose that it is the case that if we look at what the algorithm assigns to Black individuals, that score is higher than the actual success rate in terms of what fraction of Black individuals donate buildings 25 years after admission, okay? And this is very likely to be the case because of these intergenerational wealth differences and because we started with everybody being given the same score. A of X is just the probability over the population as a whole, not subdivided. So we would have such a gap And the multi-accuracy algorithm could pick the set of Black racialized individuals to be the update set. Black is chosen for an update. And then, of course, the score of every member of Black will be lowered. Okay? Because that was the way in which the nudge had to go in order to make the algorithm more correct. Okay? So all those scores were lowered. So now let's look at two people who are very high probability individuals for donating a building, X who is Black and Z who is white, and X's score has been lowered relative to that of Z. Okay. And even if there is a set in the collection that precisely identifies who are the high probability individuals for donating a building, there is nothing in this algorithm that is going to allow the score of X to catch up with the score of Z. Everybody in this set of high probability people will be raised and lowered in sync by the same amounts, okay? So you can riff on this execution. It also applies to multi-calibrated algorithms, and you can drag scores around however you want. Okay. So what happened to X? Due to structural racism, the fraction of Blacks with low true probability of positive outcome is higher than that of whites. X's score, f of X, was lowered because X was racialized Black, and Black was one of the sets in our collection. So the injustice was compounded. This is exactly what Deborah Hellman is talking about. Process matters, which I think now is the second time in this session that you've heard that phrase, that process matters. Okay, and if you're a medical person, you might recognize something that just happened in this algorithm, and that's called race correction. So we have race correction in medical algorithms, and I'll get to some examples in a minute. I want to go back to that slide that I skipped. So there's a lot of arguments. Should you be including race or not including race in medical decision-making? And there are a lot of mathy reasons to include race. So race might be holographically embedded in other features, so it's not even clear what does it mean to remove race. If you include race, you get a richer class of algorithms. You simply have more information. There are utilitarian arguments of increased social welfare for patients of all races and clinical prediction. But the include versus exclude is a little bit of a false dichotomy. So you don't necessarily sort of want to compare what happens if these are the features that I have. Should I add race or not? No, it might be a question of, instead of adding race, is there some other feature or some small set of features that might actually be more proximal to the thing you're trying to predict? Maybe the right thing to be adding is something like lower socioeconomic status, or socioeconomic status in general, or access to health care, what kind of diet people had as children, and so on. Okay. So it's a false dichotomy. Another possibility might be to train with race, meaning, of course, that while you're training something, you're checking to see, is it behaving in a discriminatory fashion or not? So there's this question that we want to be asking, which is, by what logic are people grouped together in this fashion? So if you know any kind of basic recursive function theory, you know that if your algorithm is including race, what you really have is a collection of algorithms, a different algorithm for each race in your collection. All right. And when you think about it that way, you really maybe want to think about it like, ooh, does this really sound like a good idea? And there are many ways to organize people. I mentioned a few: socioeconomic status, diet, things like this. Is it so clear that race is the right method to be organizing people? Now, my experience talking to I have some experience talking to people in the medical profession, including research medicine, that has a lot of magical thinking about race. Race has super predictive power because it correlates with huge numbers of medically relevant features. It's too expensive to replace race with these other medically relevant features. It's too difficult to identify a small set of features that could replace race. And besides, even if you found some that seem to replace race, clearly if you then again re-include race, you'll get even more predictive power. Okay, so this is the kind of magical thinking that I encounter. And do I know that it's magical? No. It simply isn't quite passing the smell test for me. So there are a lot of problems with that kind of reasoning. First of all, among them, people change their self-identified race at a rather brisk clip. And so even if you had managed to get everything right and have it working and well calibrated for year one, year two, you're now looking at a different set of people who describe themselves this way. So that's one problem, that race is not stable. Not only is it not biological, but even the self-identified race is not stable. Not to mention the fact that there are all kinds of stories, and I mean published stories by scholars about their experiences, where even though they self-describe one way in medical setting, the person who looked at them and filled in some form checked a box on their behalf, and not necessarily the way they would describe themselves. So you get inconsistencies even if somebody moves from one place to another place. Another problem is that if you talk to a statistician and someone who knows working with real data, it's not always the case that having more features is better, because there's noise in features. And sometimes adding more features is actually literally just adding another noisy variant of stuff that you had before, and your prediction deteriorates. So, but that's a kind of real-lifey thing, as opposed to an information theoretic thing. And so on the information theoretic realm, remember we said that the reason the multi-accurate predictor builder terminates is that every time you make progress, every time you do an update, you make progress. Well, if reintroducing race is so great each time, then there's got to be a limit to that in exactly the same way. If you're getting a big improvement, you can't keep doing that, because otherwise you end up at P star. So the medical community has taken a lot of interest in this, and it's very, very inspiring. Reviews American history with the view that slavery is the original sin of the country. It was invented, and so it shows up in American medical practice because there's a reason of justifying a certain, the enslaving behavior. So there's been progress, though. So estimating kidney function used to use race, and now race was replaced by measuring cystatin C in the urine. This is an improvement. It's a better algorithm for everybody, it turns out. Estimating whether a woman who has had a C-section will be able to have a successful vaginal birth. Again, used to use race, now I think it uses hypertension, history of hypertension, and so on, which is clearly much more relevant to this, to this specific case. So on the right here are some examples highlighted where there has been progress. And this paper was published in 2024. I can only hope there's been more progress since then. And finally, I just want to draw your attention to a National Academies study, which is, in fact, where I got this framing of by what logic are people grouped together in this fashion. And this was particularly focused on genomics research, and their recommendations are quite strong. Researchers should not use race as a proxy for human genetic variation. Researchers should not assign genetic ancestry group labels to individuals or sets of individuals based on their race, whether self-identified or not. Researchers conducting human genetic studies should directly evaluate the environmental factors or exposures, okay? And they also draw attention to the fact that people's self-identified race changes year over year. And that's kind of all I wanted to say. Thank you.
Thank you, Cynthia, for the thought-provoking talk. Any questions from the audience?
Thank you. I just wanted to say something. My name is Austin. I'm from State University of New York. Okay. Yes, I just wanted to say something about the use of race. I think it would have been better possibly to use dimensions of culture. Dimensions of culture. Like the studies, dimensions of culture plus the did you say eating a bit or something like that? It would have been better because first we reduce instead of hermeneutical injustices that come with race, and we fill the hermeneutical lacuna that is actually there, and it is possible to combine dimensions of culture and diet or something else and prove that those predictions will still come true, the ones that they were did in 2024.
So I'm afraid I don't really understand the question, and I'm not sure what dimensions of culture, I don't know enough to answer that. By the way, this is from the National Academy's study. Yeah.
Sorry, it wasn't a question, it's just an addition to what you're saying. But there are 5 dimensions of culture, of studies, dimensions of culture. They determine how we eat, how we exercise, whether we go to sunshine a lot or something like that, Mediterranean and others. So I do believe that. I come from Kenya, so I come to America. In Africa, we don't have a concept of time. If somebody tells you they are going to come, they will come after 30 minutes. But now I've realized that for the few years that I've been there since 2023, I'm very specific with time now. So things change because of the culture where someone is. And that one is such a better predictor of actually those are the reasons that the black race or the white race or whatever other race is being used to predict is better posited to be used. Thank you.
So thank you for having the patience to re-explain, and the point is well taken.
Hey, Cynthia, thanks for the really great talk. I was wondering if you could point me to like a more kind of specific example. Can you think of like cases where there's been a failure of multi-accuracy or multi-calibration in medicine when it comes to like disparate impacts on race?
No, due to my ignorance, I'm not actually aware of any uses of multi-calibration and multi-act. No, that's not true. Actually, I am aware of some. I know that Clalit, the largest healthcare provider in Israel, used multi-accuracy to help build a predictor for who would be at risk for severe COVID very early on in the pandemic. And the data that they had came from China. And it was, there are sort of cultural differences between China and Israel. So for example, smoking is much more prevalent in men and young men in China than it is in Israel. So the details currently are escaping me, but they were able to use multi-accuracy to help translate, do like a distribution shift, to do a prediction of who was going to do badly with COVID. And the claim that I remember hearing was that it was quite successful. So I don't know examples of failures. I only know maybe 2 examples of actual application, and that was from Clalit. But maybe other people here know more. Yeah, thank you.
Thank you.
Hi, Cynthia. Thank you for the talk. It was really interesting.
Hold the mic close to your mouth, please.
Hi. Okay, I'm a student studying data science, and this was very fascinating because I've thought that we would have to not replace race, but just exclude it completely, along with socioeconomic status and other things that might be, I don't know, for the patient, we would be unfair. So in the concept of replacing race with socioeconomic status, that was interesting to me, so I'm going to process that after. One question, it might be a clarifying question, but I do have a medical background, so I know that when physicians are treating patients, we take race into account and which medications to prescribe. So, for example, for African American males, you might want to consider hydrochlorothiazide versus
Consider what?
lisinopril or amlodipine.
I'm sorry, you said consider what for African American males?
Hydrochlorothiazide.
Okay.
I think. But would you recommend then replacing that with something like kidney clearance or hepatic function or other comorbidities rather than race in that case? Would that be more accurate?
So,
Like
the
biologically?
irony of you asking me this question is great. You're the person who would know what is it that the use of race is actually trying to capture.
Gotcha.
And so this is something where domain expertise is completely critical. And it's why we on our theoretical computer science end can't give a general method for saying, do this, because we don't know your particulars. I do know that when I talk to physicians, they'll say, well, race is really being used here as a proxy for A, B, and C. It's like, great, use A, B, and C. But I don't know what A, B, and C are.
Yeah.
Yeah.
Yeah. I was thinking the physiological differences between gender and race, you know, that kind of thing. So just generally speaking, so, okay.
And thank
That
you for
sounds good.
mentioning gender,
Yeah.
because a lot of what I said also applies to gender.
Okay.
And I think there's an article coming out by Nancy Krieger and Sarah Richardson and maybe some others that will talk about that it is, we all think it's very obvious that gender is clearly physical, et cetera, but it turns out that in many cases you don't need it. Mm-hmm. And I should also mention that one of the objections here is, as Dorothy Roberts says, categorizing me by my race, this does not feel like personalized medicine. The variable is racism, not race, and so on. Okay, Adam?
I'll ask a question to connect it to the, since we're at TPDP or the post-TPDP workshop or whatever. So when we're releasing information subject to privacy constraints or generating synthetic data or whatever, we often have, choices to make. We can't release everything, right? And so, I was hoping to hear your thoughts on, when characteristics like, attributes like race with all its failings make sense to kind of include in the set of things we want to take into account, like when, statistics we want to take into account, say, when generating synthetic data. And let me make an argument for why, like, it's not sort of, even given everything you said, it's not a straightforward question, is that, like, I could imagine a case for, like, you were mentioning, if adding race to your features would dramatically change the kinds of predictions you're going to make, that's an indication that you should be looking for other features to add, right? But you have to know, like, to even make such a decision, an assessment, you have to know that adding race to your features would dramatically change the performance of the model. And one of the things we see with DP, of course, as you know, is that sometimes it's hard to have visibility into these kind of finer-grained questions because we may not include, whatever we release may not support the question, answering the question, right? So I guess my question for you is, we consider these sort of socially loaded and constructed features, how, if you have an answer, should we be thinking about including or not including them in the sort of sets of statistics we want to preserve, say, when generating synthetic data, things like that?
That's a question I haven't thought about. And now that you're asking it, so I have two answers, and they're like competing for my mouth, and they are also mutually exclusive. So one is, well, you know, other countries don't have our history. So what do people do about race in other countries? Like, and I don't know the answer to that. I mean, I know anecdotally by talking to people, but I haven't done a real systematic study of the use of race in medicine in countries other than the United States. Okay? So that's one answer. It's like, do we really need it or not? And then, but another one is, of course, let's go back to the original reason why multi-accuracy was proposed. It was in part, I mean, yes, to fix, but also to detect that something was going wrong. And so, and that there might be some systematic discrimination going on in the predictor, possibly because the labels that were used for prediction were labeled or were biased, right? So given our history, I can also, this is the other answer that's competing, and I don't know how to resolve it yet. Yeah.
Thank you.
Thank you. That concludes our first session. Thank you, Cynthia. Thank you to all the speakers. We are running a little bit behind schedule thanks to the great talks and discussions. So we're going to have a shorter break, and let's come back 3:15 for the panel. Yeah? So, okay. All right. See you guys.